Hello, everybody. I wanted to debrief these sketching cotangent, tangent, secant, cosecant problems. The general idea is what we practiced in class. If I want to sketch tangent pi over 2, I know there's going to be some vertical asymptotes. So my first step is to sketch either a sine or a cosine function to help me visualize where those asymptotes are going to be. You know that tangent is sine over cosine. Let's get this pi over 2 in there. And you know that when the denominator approaches 0, that's what makes the y values approach infinity or negative infinity. So that's what's creating the asymptotes. So I want to sketch a cosine function because that's going to show me where the asymptotes are. Okay, so if I'm going to sketch cosine pi over 2x, I have to think, what's the period? How long is one full wave? And we talked in class both about these equations and also why they make sense. The period, so this number here is the frequency, and the period is 2 pi divided by the frequency. So if I want to find the period, I've got 2 pi divided by pi over 2. Let's invert and multiply. So that's 2 pi times 2 divided by pi. So now pi divides pi, and that gives me a period of 4. So let me go ahead and label this. Here's going to be 4, 2, 1, 3. I'm going to go ahead and sketch cosine. I'm going to make this 1 and negative 1. So here, let me do it in pencil. So my cosine graph goes from its maximum value to the mid, to the lowest, to the mid, and back up again like this. And if I was going to sketch, let's go ahead and sketch one more period here. Like that. Okay, so what do I know? I know that at values of 1 and 3, that's where the vertical asymptotes are going to be. And then let's sketch in a little bit more. For me, it wasn't important on the test if you did multiple periods like this. I just wanted to show you. And we know that the zeros of the function are going to like the x-intercepts are going to happen whenever the numerator is 0. So if I wanted to, I could also imagine graphing sine of pi over 2x. So it's going to have the same period, except it's going to go, let's do this in blue, it's going to go from mid to top to mid to bottom to mid. So that would be sine. And here are the places where sine equals 0. So I know those are going to be the locations of the zeros of my tangent function. And then the last step is you could either have just memorized which direction the kind of S-shaped curve goes, or you could think about where is the graph positive and negative. So I can see, I guess let's do 0 to 1 here. In this interval, both sine and cosine are positive, which means that tangent must also be positive. It can't go down that way because that's negative y values. And a positive number divided by a positive number, sine and cosine, has to be positive. Whereas in this interval from 1 to 2, sine is positive. You can see that because blue is above the x-axis. Cosine is negative because you can see the pencil cosine graph below the x-axis. And a positive number divided by a negative number is negative. So that must mean that the y values are down here somewhere. And so the asymptote forces my y values to negative infinity, and so I know that that has to go that direction. And so that lets you fill in the rest of the curve. So that was the intended process. Let's look at this one. So this one I said it's a transformed secant function, so we know that secant is 1 over cosine. If it's 1 over cosine, we know that the secant function sort of fits with a cosine function this way. So if I want to know what the secant function is, I would need to figure out like what's the period of cosine, because that's what's going to be the number I write in here is the frequency, and that number is going to be the same number I'd write in secant. For example, if I have secant of whatever, triangle x, that's the same as 1 over cosine triangle x. So if I figure out what the frequency for cosine is, that'll tell me the frequency for secant. And that's what I need to write the equation down. Okay, so I see for cosine, it starts here, it ends there. So the period is 2 pi over 3. So remember, frequency is 2 pi over period. So 2 pi divided by 2 pi over 3. Let's invert and multiply. That gives me 2 pi times 3 over 2 pi. Those divide, and that just gives me 3. So I know that this is going to be secant 3x. But if it was just regular secant 3x, this would all be shifted down a little bit. Notice that this cosine function, this is 2, this is 1, this is 0. The cosine function has just been shifted up by 1. The amplitude's the same. That hasn't changed. It's just that everything's been shifted up by 1. So the real equation here would be secant 3x plus 1. So that's the idea. I was hoping to have you make connections between the graphs that create cotangent, tangent, secant, and cosecant. So make connections between cosine and sine and these sort of harder to visualize graphs. Okay, I hope that this was helpful. If you're going to practice this, I think good things to practice are just finding the period, finding the frequency, going through the logic of why does the curve face up or down in certain intervals, remembering how secant fits with cosine or how cosecant fits with sine.